everyone, this is an update for the HypeRail. So I'll be talking about the electrical, the code, and the mechanical part of this. So the only mechanical update on this is this part that goes inside. So now it has a little more spacing in here. What it does is that it accommodates for a double winding of the string. Other than that, the mechanical part is the same. We've upgraded, or we're trying to move over to a different microcontroller. That's the Feather M0. So that's this one right here, and that's what I have set up there. We're still using the same separate motor driver, and I'll move over to talking about the code. So in terms of the code, the first code that I wrote was supposed to be modular in terms of moving it over to any microcontroller, and that seemed to work. The only thing I had to change for this code is the pin definitions and put some waiting in between outputting anything. So this while not serial waits until the serial port opens, and then it starts sending or prints this R out through the serial. And what that does, it sends that over to processing. So this is the first thing that we see right there. And what happens is that once it receives that R, it knows that the microcontroller is ready to be, or it's ready to receive a command. And without that R, you don't know whether it's set up or if it's still setting things up, or if it's stuck somewhere. So that R is very important. So the only real need of any microcontroller is that it can communicate through serial, and that it can make pins go high or low with a certain amount of time between, and it has to be able to do that within the microsecond range. So that's the only thing that changed in this code. So let's give you a demo. So we'll re-upload. And then rerun this. You can see here the first thing that came through was that R. So we know that the microcontroller is ready, and then let's start setting this up. So we want a rail length for this one. Let's just do 0.5 meter. Spool radius 10, and the velocity, so you can actually see some movement. Let's do 100 millimeters per second. All these variables get updated as soon as they get entered. Here's our all inputs. And at the end, it just gives you delay time, which is really important for the moving of the actual carriage up there. So that number at the bottom is in microseconds, and that's the time it waits in between going high and then going low and then going high again. So we got everything set up, and then let's just hit travel, and see if it works. Yep. And that's it for this update.